Hello everybody, welcome to my talk about the idea of networking file Linux tracing, or how Linux tracing can use the networking subsystem. My name is Alexander Aring, and let's start. So why this talk? First of all, I need to admit I don't have any code yet. I'm sorry. This is just an idea which I had in mind some months ago, and to make something with Linux tracing and the networking subsystem. Any kind of feedback is welcome. So I have no idea if this can even work, if it's even a good idea, it's a bad idea, it's just too crazy. I don't know. And yeah, what this idea is, to explain my idea, I will at first describe some tracing basics from the Linux kernel. That's the buffer handling, how it currently is in the Linux kernel for the tracing buffer, and a filtering mechanism which is used for tracing in the kernel. And yeah, it is very basic. The reality is more complex. And yeah, first of all, there's tracefs. This is a special file system. It's providing a UAPI to control the Linux tracing subsystem. It's like proc or sysfs, where you can control everything with also core utils like echo and cat. Like echo 1 enable tracing, and then tracing is enabled and 0 disabled again. And there's also a lot of other files where you can configure everything. And it's usually mounted in syskernel tracing. So there exist a lot of different mechanisms to provide a trace point for the Linux tracing subsystem, but you're probably most familiar with this one. This is to declare one in the code. Here we have the trace event macro. For example, the name sk data ready. This is already taken out of the sock.h header of the Linux kernel. Then such trace point declaration has some fields where you can put the actual state of the socket structure, like the family field and the protocol field. Then you have some fast assigned where you make copies of these fields for the tracing buffer. And for some tracers, you have a format string to have a pretty printout. This is provided by the trace point. So a trace event is actually a trace point instance. So a trace point generates can generate multiple events. Like for example, here this my data ready function. It says trace sk data ready. Data ready is a common socket callback to signal the user that there's something ready for the socket queue to read out from. And it generates a lot of events, and I'm not going a lot into the details how the raw format of the trace event looks like, but in a very abstract way, it has some name, and then like the sk data ready, and then it which can reference to, and it has a lot of TLV fields like the family and the protocol, what we saw earlier. And the TLVs, they are very generic type length value. We say what kind of type it is, how many bytes it takes, and then the value field. And then you have a lot of stream of events, very simplified, which are written to the tracing buffer. And this is looks like this, that each CPU which is running hits a trace point, and then it wants to write the trace event into the tracing buffer. And the tracing buffer is actually a list of pages in a linked list like this. It's more a ring. The end refers again to the head. But this page pool for the producer of trace events, it's per CPU. So another CPU has also page pool where it writes the events into it. That's the reason why. The reason is because it probably already cached everything to access these pages, and then it's very fast accessible and it's very optimized. So the consumer part, to read out the trace events for the tracer, for example, here in this example, we have a user space tracer application. It has these file descriptors open, which is accessible over the tracefs. And there's a per CPU trace pipe wall where you can read out the trace events, which from the per CPU page pool, and then the trace event trace application shows them. A point about the tracing event filtering. There's actually an in-kernel interpreter. Yeah, there is one interpreter in the kernel. It's the tracing currently use it. It's a trace events in filter.c. In this source file implemented. When you open it, you can already see there's a enum with all the operation for equal, greater than, less than, unequal, to compare numbers and strings. This is how the trace filter can be programmed over the trace fs, and then the CPU will filter out the trace events. So a point to mention here, there's a difference between kernel tracer and user space tracer. A kernel tracer is, as the name propagates, lives in the kernel, like the function tracer, the function graph tracer, OS noise, and other things. And then you can run some cut on some file to read out the kernel tracer. Whereas in the user space tracer, it, as I showed, it has these file descriptors with the trace pipe wall. And that's, for example, kernel char and trace CMD. They are user space tracer. I make also the difference between local tracing and remote tracing. Local tracing means that the tracer application runs local on the machine which need to be traced, which want to be being traced. And the remote tracing is a bunch of machines in a distributed network. They're generating trace events, for example, when you're observing some networking protocol. And then one machine in this network receives all these events and combine them together. And ideally, you want to have them time synchronized, that they are in order as they appeared in the network. And time synchronized because you can then make timing measured about how long different things was happening according to different trace events. So how we can adapt this to the networking subsystem, the producer and consumer, I was thinking about to doing that with the DMA rings on the NIC. And when we having it on the DMA rings, we can also use the NIC ASIC to offload the filtering, which is currently done over an interpreter. We can offloading it on the NIC by using TC, for example, U32 classifier and then action drop. But we can also do classification like giving this specific trace events with a specific field values, specific numbers, SKB mark in this case, to putting them in categories. You sometimes want to do that if you have a hierarchy in your trace events and want to hash them into different numbers. It is the same use case as why SKB mark is being used. But I was also thinking we can also use P4. And when we directly operate on these DMA rings, why we cannot just having the user space tracer open XDP socket, which directly operates getting the data from the DMA ring to the user space, which are without bouncing buffers around. So that is the first basic idea, which I had. How to do that in more detail is maybe encapsulate the raw tracing data in some link layer, maybe Ethernet, something what's being useful. If there is a use case with IP to route the tracing data, why also not doing that? And for local tracing, I was thinking when you're having the transmit and the receive buffer on the NIC, can we already redirect the same data to the receive buffer on the NIC and having the ASIC control this? I'm not just an expert if this is possible on all NICs, but depends on the hardware. There's a lot of hardware questioning here. I don't want to hide that. And if this is not possible, why not just using one of these loopback cable when you're having a NIC with 2 ports on it, that one port is transmitting, the other one is receiving. This should be also possible. And the remote tracing is, when we're having directly on a DMA ring with some Ethernet, something addressable on it, that can be received on another node machine in the network. Why not just sending out the tracing data that it lays on the remote machine DMA ring of the NIC as well? And of course, when we're doing that, we need to have this all also time synchronized, as I mentioned before, because you want to have them somehow in order in your tracer. So how does it look like in a producer? I just was making a simple graphic here. So the CPU hits the trace point and it writes the trace events, the trace event in the raw data into the transmit buffer. And my question here would be, can we somehow pin one of the DMA rings? We have multiple of them. At least I have them on my NIC. Can we somehow pin them also to a CPU that only a CPU is assigned to a DMA ring? But I think I don't need to make some additional minds about that. What I just want to use is the AFXDP implementation, how they doing that, and try to adapt this. But what I know is, for example, the NUMA node requirement, because we don't want to traversing over internal bus from one CPU to another NUMA node where the NIC is attached. There's also another Netdev talk on this Netdev which talks about this problem, and we should avoid this as well. I'm not sure how to avoid it. I need to look at more, but this is probably a problem where we're running into it. But I think when I'm using the already existing infrastructure, how RFXDP is using the DMA ring on an abstracted level, then I need to then maybe these things getting in a simpler way solved, but I'm not sure about this. And on the consumer part, on the transceiver buffer, we read out the trace event or data. Then we having a Linux network interface. And for example, for AF XDP, we can read the raw trace data and have them directly in the user space. So between the transmit buffer and a redirect to itself on a local tracing path, pass, there's and then hitting the receive buffer. The question here is, can we actually getting so there's the ASIC involved, which can then drop the trace events, and probably we can offload the trace event filtering instead of doing it on the CPU with the interpreter. So in case of the tracing filtering and the networking subsystem, we know that the kernel need to know all the metadata, how the tracing data is constructed with the TLV fields. This can be all discovered by the tracefs. And I was thinking about writing a user space application on top of IPOR2 with the TC command, for example, or making eBPF, that it knows all these key value pairs from the tracefs, which can be discovered. And then we making a bunch of U32 classifier commands with TC, and then the action drop, or also SKB mark, depending what you want with the doing. And there's another issue which I was thinking about, except besides the tracing filtering, it's about trace event dropping. That's a topic in the Linux tracing, and they also want to avoid buffer bloating. Is just to make more another connection with Linux tracing and networking, and about also reliable tracing that no trace event gets dropped. And maybe we can introduce some reliable protocols which are also in the networking area and avoid buffer bloating. I write here QDisk for Linux tracing ? If this also can be used to make this behavior at least better in Linux tracing. And also if there is a drop and which event to drop, this is all a topic in the Linux tracing world. So the next step, what are the next steps? So I was thinking about at first a proof of concept. Ignore all the DMA ring buffer now, which I explained before. I just want to have a virtual networking interface and a local tracing example that I wrote it here, that put trace events in a socket buffer, and then that this socket buffer is received by the virtual tracing interface. And then we run something like Wireshark and look that we can use Wireshark as a Linux tracer, because we don't need to change a lot of things there. It directly will show us the raw tracing data. And these are the TLVs, and also maybe we can make a dissector which is configurable over runtime to discover the trace FS and the metadata of the trace events. I'm not sure if this is possible in Wireshark, but at least we can see some raw tracing data. So if we have that, then I would just build these tool on top of TC IP route to implement the U32 commands to classify on specific key value pairs of the trace event, and then it's get programmed with an action drop, and then we can see if this trace event is still showing up in Wireshark. Then I also wrote something about remote tracing, but I'm not first interested into that. Maybe we can simulate this over VEs. And then we can look into the performance and try to use real hardware, use the DMA rings, which I already explained before, and the ASIC to doing the filtering, offloading. And I would look here into the AFXDP and the NetCore page pool implementation. I think this can be useful to do that. And the more future step is then this time synchronization. And the last Netdev, Willem, was making a talk about how he was doing something like that with SO timestamping. Maybe this can be also being used. Otherwise, maybe we can add additional metadata TLV for the clock offset into the trace events. And this is then for the causality requirements that the events are in order as they appeared in the network. So thank you everybody for to listen to my talk. And are there any questions? Hi. So yeah, I got more ideas.
Sorry.
Somebody
yes,
has questions?
Can you hear me?
Yes.
Okay, we do have questions in the room.
Okay.
So I don't know if is this mic working?
Yes.
Okay.
It works.
All right, good. So one thing I wanted to point out is that for Wireshark, it's going to be really difficult because you always need the trace file system information to really understand what an event means, right? You don't literally have the name of the event, you have a number and in the binary buffer, right? And so you're always going to need that that extra information to be able to parse an event that has the metadata of that event. So I think that's
but the metadata is
to get that remote.
Yeah. But the metadata is discoverable over TraceFS.
Yeah. But you're going to have to ship it to the remote site.
Yeah.
When somewhere else.
Yeah, that is correct. That is correct. It can be the initial state. I know when they have somehow the TraceFS format, the file format from TraceCMD, which I think is using the raw data format. They also need to store all the metadata into it.
Yeah, so when you use trace command, it will record all the metadata at the very end when you finish the tracing, which is one of the problems I have with it, because if you reload a module or do something like that, you lose all of your metadata and it just gets useless. So that sometimes can be an issue.
Yeah.
So really, though, the other question I wanted to ask is like, what are you trying to get out of it? Is it just the filtering, or is it just to be able to ship off the camera? So, or is it the being able to ship the tracing out of the system more quickly, or is there some other theme to this?
Yeah, I'm working more on the distributed log manager in the Linux kernel, and this is a distributed protocol, and I want to trace my whole networking protocol as I showed in the talk with the remote tracing, with the remote tracer example.
For DLM though,
Yeah,
you need that high performance for
not
the
really.
tracing.
What I
It
need
seems like
is, yeah,
sorry, go ahead.
what I need is time synchronized tracing, and so far I see with all, there is a trace CMD time synchronization feature into it, but I need to look into that because it was only working with vSOCs in my experience. They have a PTP implementation in the user space, but yeah, it needed to be either changed or doing this idea here.
Right. Okay. The trace command uses the local CPU clock, and even in a NUMA system, sometimes you can have issues with time synchronization within a machine, right? So yeah, okay, that makes sense. Thanks.
Yeah. So what I want with time synchronization is that I can maybe also use the NIC time synchronization offloading to get the metadata somehow out there to take advantage of this. But it could be also made in TraceCMD with the agent implementation to get out of this. But I also was thinking, when I was looking in the code and how the TraceCMD is currently handling that, why not directly put it into the buffer of the NIC and send it out? And also with the filtering, I can think about, there's actually I did not mention that in the talk. There is a page pool tracing buffer benchmark, and maybe it performs. The goal is to perform better, even with and putting the filtering on, and look if offloading is an advantage or disadvantage. Yeah. And I got a lot of ideas yesterday with the NAPI ID talk about to pin more a specific NIC to I think it was about pin a NIC to a specific thread which handles then the socket to have a lot of
the IOU ring discussion.
Yeah, the thing what tracing is more focused is cache locality, and I think to choose a NIC where the trace event buffer is going to be stored to have this performance, I'm not sure if this is actually an advantage. I need to make experiments and get it to work to see if it's actually a benefit. But also, I mean, if you look, somebody ever looked into the TraceCMD implementation about how to read out the raw trace pipe? It is a little bit complicated. It would be only nice to have such a socket interface to get more a stream of data out of it. But yeah, I need to look into it. Are there more questions?
It might be a little bit of the same question, but I understand the idea for like remote tracing. If you put the trace onto the network and have it go out the network, another system, that kind of makes sense. But I was kind of struggling to understand your vision for what's the point of putting it on the NIC for it to come right back to the local host instead of doing that all in software, in memory.
That was the advantage about having the ASIC in the between, and then you could have filtering, especially in my use case where I want to make a network, where I want to trace a networking protocol. I have a lot of hashes where I need to have some log ID, log space ID. They have a specific hierarchy, and I need to put them into a specific. I need to analyze every field and put a hash out of it. And this is the exactly use case which I would do with a classifier in TC and SKB mark. And then I have already a number, and I don't need to don't need to do that in software anymore. I can directly offload this, and that NIC is giving me a ID for a specific trace event. Which does it make
Make
sense?
some more context on like what the benefit would be. Yeah.
Oh, okay. That is the basic idea. The thing is, if it's actually giving us a benefit, or it takes more longer than with the local tracing case, if it takes longer to put it actually in the NIC or just run the kernel interpreter on the filter and have it work like TC. Also, maybe TC can directly put it into as a replacement for the kernel tracing buffer in a local case.
Yeah. And certainly if the trace data could be read out of a socket interface or an interface that's a little easier to use than the existing trace, probably have some benefit even if it didn't end up going over and over devices. So there's
but
true thoughts there.
You need to have more. I can think for a whole framework, you need to have more high level libraries, as Johannes said, to get metadata interpreted, because they are numbers, and then these numbers need to be getting out of the tracefs file. For the local case, okay, this can be done for the. So actually, I need to look if the benchmark if it actually does a benefit at the end with the local tracing and the filtering over the ASIC.